Alright, we are solving exponential equations, and I always like you to see what we're about to do so you can lay your page out appropriately. We're going to make little mini equations out of all these, and this looks real intimidating, but it's called an exponential equation because the variable is somewhere in the exponent. And when you start, what you have to do is just focus on the bases, and you want to go small. So when you see things that are powers of 3 and powers of 2 and powers of 5, powers of 4, you need to think about, how do I go small? Something happens in 7 and 8 that you might want to think about also. 25 is 5 squared. If it's under 1, it means you have a negative exponent. 27 is 3 cubed, so 1 over 27 is 3 to the power of negative 3. So you do need to know your arithmetic and your powers of 2, 3, 4, and 5. Once we know that, we can move on to the big problems. So let's take a look at what I can do with my exponents. I have 3 to the 4th equals 3 cubed raised to the m minus 1. And that's really 3 to the 3m minus 3 on the right-hand side. I'm going to get to this place and stop on all of them. I have 2 on the left, and I have 64 raised to the 3n plus 1, which is the same as 2 raised to the 18n plus 6. That's kind of big. On the left side, if there's nothing there, a lot of people like to put a 1 as a placeholder. Number 7, I have 1 over 25 raised to the 2n, and that's the same as 5 to the negative 4n. And on the right side, I just use the problem, or the exponent that came in the given problem, n minus 5. I have, a quadratic on the way. I know that because I see an x squared. And then I'll just use this negative 3 I got when I translated to a base of 3. Number 4, 4 to the 3y plus 5, that exponent, kind of ugly, but stays. And you know what? I'm not going to do anything different just because I have an inequality. It just comes along. This problem is 16 raised to the 2n plus 1, so it's really 2 to the 8n plus 4. And again, bring along the inequality. Now what do? Here's the key to all of this. You've gotten the same base in each problem, so you're going to set the exponents equal, and you make a little mini equation. So I'm going to set 4 equal to 3m minus 3. When I bring it over, I have 7 equals 3m, and m equals 7/3. You're going to get fractions, get used to it. You're going to have 1 equals 18n plus 6, or negative 5 equals 18n, or n equals negative 5/18. Again, it's a fraction, it's okay. When I look at the one on the upper right, I have negative 4n equals n minus 5. When I bring the n over, negative 5n equals negative 5. We love this answer, n equals 1. People feel comfortable with that one. Now my quadratic, yay! When I set my exponents equal, I have x squared plus 4x equals negative 3, but I know I solve quadratics by setting myself equal to 0, so I'm going to add the 3 to the left side. I have to factor this, and I get x plus 1 and x plus 3, and guess what? It just means you have 2 answers to this problem, negative 1 and negative 3. Now for the inequality section. Guess what? Same thing happens. I'm going to set the exponents instead of equal. I just bring down whichever inequality came in the original problem. So in this problem, I'll have 3y is greater than or equal to negative 3 when I subtract 5 over, and y is greater than or equal to negative 1. That rule, if you're thinking about it, says when you multiply or divide by a negative number, you would switch the sign, but 3 was positive, so you didn't have to do it here. And in the last one, I'm going to set 8n plus 4 less than or equal to negative 5. So 8n is less than or equal to negative 9, n less than or equal to negative 9/8. So again, get the same base, go small, go small. And your powers of 2, 3, 4, and 5 are usually what are going to help you. Happy solving!